In this section, we want to learn about the factoring binomials. There are three important formulas you have to remember from this section. Those are difference of squares. That's a squared minus b squared equals a minus b times a plus b. Other important formulas are sum of cubes and difference of cubes. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. And difference of cubes is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. You have to notice that there are some subtle confusing points here. If that is a cubed plus b cubed, then it starts with a plus b, but it goes like a squared. It should be minus ab plus b squared. If it is a cubed minus b cubed, then it starts with a minus b, and then this part, a squared plus ab plus b squared. This sign is opposite of what's originally appearing here. All three formulas are fundamental formulas you have to remember. Other important remark is difference of squares is a squared minus b squared. It's not about a squared plus b squared. If that is added, then you cannot factor. In factoring binomials, it's important to recognize the pattern of the binomials. When we have z squared minus 16, there are two terms, so that's binomials. We can rewrite it as z squared minus 4 squared. Then by applying the difference of squares, we factor into z minus 4 times z plus 4, direct application of difference of squares. The next one is 4y squared minus 25z squared. Each term consists of two factors, and we realize that 4 is 2 squared and 25 is 5 squared. So we can rewrite 4y squared equals 2 squared y squared. That can be rewritten as 2y squared. And 25z squared can be rewritten as 5 squared z squared. That can be rewritten as 5z squared. So given binomial 4y squared minus 25z squared can be rewritten as z 2y squared minus 5z squared. So we can apply the difference of squares formula. Then it becomes 2y minus 5z times 2y plus 5z. Next problem is 98u squared v minus 2v cubed. This is a binomial, and definitely it is not difference of squares pattern, but after you take out the common factor, you realize that this is also the pattern of binomial, or the pattern of difference of squares. In each term, we can see v. V cubed can be written as v times v squared. So we take out the common factor v. Then we have v times 98 u squared minus 2v squared. This is an even number, and this is also an even number. So the common factor is 2. So 2 times 49, we take out 2 here. Then we have 2v times 49 u squared minus v squared. And 49 is 7 squared. So we can write 49 u squared equals 7 squared u squared. Then that's 7 times u squared. Let's rewrite it as 2v times 7 u squared minus v squared. Then that'll be 2v times 7u minus v times 7u plus v. Now we want to work out the problems that uses sum of cubes and difference of cubes. In the first binomial, we know 27 equals 3 squared, 3 cubed, because 27 is 9 times 3. And 8 is 4 times 2, which is 2 cubed. So 27 can be rewritten as 3 cubed, and 8w cubed is 2 cubed times w cubed. That can be rewritten as 2w cubed. So plus 2w cubed. So by applying this sum of cubes, we have addition of the base numbers 3 plus 2w times base number squared, which is 9, minus multiplication of two base numbers, 3 times 2w plus second base number squared, 4w squared. So that becomes 3 plus 2w times 9 minus 6w plus 4w squared. The next one, we analyze similarly. What we want to see is how the results become different. Let's start with 3 cubed minus 2w cubed, because the only difference we see from here is middle part sign. So by applying the difference of cubes formula, we have 3 minus 2w times first one squared, 9 minus plus, we have to switch the sign, first number times second number plus second number squared. So we are getting 3 minus 2w times 9 plus 6w plus 2, 4w squared.